Hello? Okay, so we're gonna go ahead and get started. It is 4:01, I believe. So we're supposed to start at 4. Good afternoon, everyone. I'm Rolando Vega, and happy you made it through the day and you're here to support this presentation. So I'm gonna be talking about San Antonio and what our electric utility is doing in the area of big data analytics, and how we have a perspective about people. Analytics is the business of people that is done by people and for people, and it's kind of very easy to be carried away with all of the technology buzz and the discussions in many conferences, not just these conferences. We spend a lot of time talking about technology, and we may at times forget the aspect of people. So I'm gonna try to drive that message home today. And the agenda for the discussion, I want to present a brief video that will kind of depict it will provide the notions of scale and time in Texas utility industry. And I want you to pay close attention to both scale and time as I navigate through a little bit of history in Texas to make a point at the end. Then next, I'm going to be talking about protocols/standards and how important they are to mobilize an industry. And I want to mention that because there is a lot of similarities to what our ERCOT, who is our independent system operator, has created a market already for utilities in Texas. And the role that protocols and standards play in really enabling a market is something that I would like for us, a data and the analytics community, to pay attention to, because if you're looking for business opportunities, you better keep an eye on what the protocols and the standards are, and what are the similarities in the history of the creation of those protocols and those standards, because that creates essentially your very next opportunity. And I want to encourage you all to look into those, because wherever you volunteer and you participate in those committees, that's essentially what drives your next big business opportunity. And I want to encourage that, because the more of people like you that support those things, if you're just in a data and the analytics community, that could be seen as an industry on itself, but it is often very good when you can focus on a particular industry, such as energy, and you can transfer all of that knowledge and essentially make money for either yourself or your company. And that's kind of the recruiting effort that I'm doing right now, not to recruit necessarily for CPS Energy. I want to recruit people that have data and analytics capabilities for the energy industry, because you are the ones who help us accelerate the adoption and the creation of new markets. Next thing, I want to mention some things about the finality of technology. Then I want to kind of make a mention of what our CEO and our executives are wanting to do, and they have been guiding all of our enterprise to the business of people. And our philosophy is people first. And then next is to kind of highlight what is the turning point for us in machine learning and artificial intelligence. You have seen the turning point from the technology providers. I want to provide the turning point from an energy company point of view. And then I want to share some highlights on some exciting stuff that we're doing on our data ingestion and some of the new projects or use cases that we're working on at home at CPS. And I want to illustrate that as a new market opportunity. And then last, I want to kind of provide a snapshot of where we are in our evolution and maturation of analytics. So first, let me drop the mic for one moment. Okay, this video goes super fast. I didn't kind of sync it with an audio or anything like that, so I'm going to be speaking over it. The first thing that was mentioned, this is the one that I told you, pay attention to scales and time. 1941, after World War II, the Texas Interconnected System was created. 24 years later, the Northeast had a blackout, and ERCOT was created. 11 years later, ERCOT had a central operation. We are now, where? 1976. ERCOT had a central operation. From 76 to 1990, that is the amount of time it took to create a competitive power industry. And that's where you note, in Texas, this is the area, the domain of ERCOT, our independent system operator, and we had zones, north, south, east, and west zones. And pricing and supply and demand were controlled in those zones, meaning that they had the freedom to change dynamically. In 2000, market protocols were developed to control that competitive market or to really create a market opportunity that was better orchestrated. 3 years later, the nodal market design begins. This is, to me, what is really exciting, because what you see here as a depiction or a transition between zones and nodes is a significant contrast. We're going to see these repeat at a different scale. The nodal market was to essentially recognize that what we were doing from a zonal perspective was not granular enough, was not good enough, because there was a lot of locality issues. Oh, this thing kind of continued. Hold on. I'll just speak over that. So they wanted to provide more granular pricing and to account for congestion of power, and whether it's because you had a lot of generation going into a given node or a lot of demand going, kind of extracting energy from a given node. And essentially these nodal market design that started in 2003, only 7 years later. The design started, 7 years later, the nodal market launches. That's, you know, from my point of view, very, very fast to create a whole industry around it. And we're just talking about 7 years for the whole of Texas. We essentially are going to start to see, I think, I skip over one, I think it was 2007 or so, where ERCOT donated to the open source community something that they call the Macomber maps, essentially providing an open source visualization of how the market looks over all of ERCOT. And that's something you can actually just go to GitHub and make your own use of it. I need to mention that, 2010, CPS Energy was the very first one to actually install and deploy a solar utility scale power plant in ERCOT. And a little later, ERCOT launches its first app, 2012. Oh, 2013 is when the Macomber map code was released to the open source. So what is next? Let's imagine what would be next as we're zooming into the scales and time scales that we're talking about. And you now, again, we're imagining that, because I don't want to necessarily show every single distribution feeder that we have and into the open source, it may be sensitive to release that information. So this is made up zones that kind of generally portray the area of every distribution grid within our territory. But as you saw before, that there were zones in all of ERCOT, and then there were nodes in those zones, readjust your scales for just a moment, where we in fact have zones of distribution feeders, and inside those zones you have hundreds, if not thousands, of little dots. And essentially we are in a microcosm of what has happened before. Every distribution grid would have its own reliability. And we would have to assure that the safety and that reliability of the power is there, and we would need to enable those transactions. And someone is going to ask me, oh, are you talking about blockchain and all of that? I'm not even going to get into blockchain discussion today. There is some maturation that has to happen in blockchain. But certainly data, whether in blockchain or not blockchain, there has to be a good sense and definition of the data flows. And so now imagine that in every one of those zones you have distributed solar generation, distributed storage, whether this is the batteries at home storing energy, and you have a market where maybe homeowners or businesses have a preference and they say, you know what, we may not want to buy energy from our electric provider. We are going to generate our own electricity, and we're going to store that electricity, and we're going to have our own little microgrid for our own. Not so easy, but at least the ideal is there. Who wouldn't like to be entirely free from having to pay a monthly bill? I shouldn't, I would point out that the concept would be kind of nice, but it's not so easy because you still rely on an electric grid to provide the electricity when there is non-renewable energy. And so it's not like the public can really get rid of a utility just like that, even if you had solar instrumented in every home, even if you had storage in every home. And so what we're going to see is a very interesting dynamic in economics, because we still have to pay for an electric grid, whether people attempts to become independent or not. And so prices may go up. We don't know. But certainly CPS Energy has a strong commitment to its people. We're the largest municipality-owned utility in the country, which means that we're owned by the city of San Antonio, which means that the people of San Antonio owns our utility. So we're looking for what is the best that we can be doing today for our people of San Antonio. And that is what is driving me to be here presenting today, because I want to continue challenging our data communities and our data analytic communities so that we're bringing and we're creating a vacuum in the San Antonio area as really a center for innovation, a center for trying new technologies, and a center for creating those new algorithms that can be demonstrated for the electric utility industry. So with that little video, I provide a little bit of a notion of scale and time. I mentioned that there are some market protocols, and I wanted to make a point about that. So if you look at these bullet points here are essentially chapters within the ERCOT protocols. You can essentially go point by point, and if you change the concept of transferring energy packets, which is what these protocols address primarily, with the exception of 2 chapters that deal with information systems, which is data acquisition and aggregation, and the market information systems. Everything else essentially is about the management of electrons and the flow of power throughout the grid. If you think of flow of power and now transfer that to flow of data, you essentially have a foundation set of protocols that really enable the set set of protocols that we're yet to develop. We need to be talking about data scheduling and dispatching. We need to be talking about ancillary services. Ancillary services are essentially those power plants that remain available to deliver very fast on demand, just like the conversation of streaming analytics or data streaming. When you need to feed data very quickly because there was no data before, you now are able to feed that information like you couldn't do before. So similarly to ancillary services, there would be an analogous to the data sector in their support of the energy industry. Congestion management, we're going to experience a similar sort of issues about data flows creating bottlenecks in our infrastructures, whether it is peer-to-peer communications that still need to be registering transactions and it needs to be auditable, or some other congestion. And so outages, for those in IT, you experience all the time outages from servers, outages in services and applications, and these are the same discussions we have been having in the power industry. So a lot of transferable knowledge that need to be leveraged, and I won't go into every one of them, but think for a moment about the renewable energy credit trading. I'm going to just plant a bug in your ear that renewable energy is a fuel that is free, and you're just capitalizing on the transfer of energy from one system to another, to mechanical and electrical energy. The analogous to the data community would be essentially open source. And how far do you take free fuel, free coding, free software, free libraries to the capitalization of energy of some kind? And so just to make a point. You can continue kind of these isomorphism, I like to call it, is really an analogy that you can derive from the protocols of today and the protocols that we are yet to develop. And we need you guys to work on this together. I want to kind of bring the point that the finality of technology is by and for people. Technology is not for itself, despite the new trends in artificial intelligence that, AI is going to take over the world and essentially humans are going to serve, robots and machines. I don't think that we're either quite there or that is the intended goal of AI and machine learning. It's still by and for people, and electric utilities are no exception. You're going to see that you have someone on one side providing a service, a given element, and I'm going to discuss the different elements, and that service is done for a group of people or an individual. So I want to recognize some of the big data analytic dimensions, at least the way that I see that, and that is that you have the hardware and the software discussion, you have the data discussion or the data dimension, you have the methods or the algorithms that create the insights, and then there is a variety of other elements which are intangible components that we sometimes either skip over it or that we are very, myself included, very shallow in the conversations because it's a very, very hard subject. And it can become a bottleneck if we don't address it up front, and we're very brave to have those conversations up front. Certainly that has been one that CPS Energy has been tackling right on its face. We have been having a lot of very interesting, intense conversations internally because the intangible element is very, very important. And that includes processes internally in a company, the relationships of people in the company, policies in the company, information flows, interpersonal interactions, internal states of mind, such as feelings, values, and beliefs. And I think that in this conference here in DataWorks, we focus primarily on hardware, software, as well as methods. We essentially skip over both data and the intangible components. I'm not addressing today very deeply on the intangible components, although it's my intent that the element of people is realized and that we all need to pay more attention to. And I kind of dig a little more on the data as a representative of the energy industry. So some perspectives on how I have seen I have mentored over 60 students in my time at universities before, and even today we have interns working with us at CPS Energy, and I see a certain evolution that I would like to kind of bring to everybody's attention. We sometimes get so narrow focused in what is the problem at hand, and we are still very reactive. Even as we're trying to create a little analytic tool or algorithm to deploy, we're still dealing with reactive issues. And when there are events, essentially we react to those events, and that's a response that is to a snapshot in time. And when we take and collect all of those events and we analyze them all together, that's when we start to understand and adapt to those changes in events over time. When we take it one step further and we kind of start designing to predict, and I think the ultimate goal is to kind of change the state of mind, to transform the system. And I will kind of go over how, a little example. So we could see that in the case of of an electric utility, if a power plant has a forced outage, for example, you have kind of the power plant operators, and then you have the market operators, and let's just, as a matter of an example, kind of define that the one on the left is the plant operator, and the one on the right is the market operator. And the plant operator identifies, oh, we had an outage, and thank you so much. So if we have that, that forced outage, we respond, we have to react. So that means that people is going to jump into solving, doing the forensic analysis, what happened, what went wrong. In the meantime, the market operator has to find alternative ways to still provide the power because they are still accountable to the market to deliver that power. To move to the patterns level would be, let's get all of the forced outages that we have seen over the last year, and let's see if we find, what is common, the commonalities in my data. And we can see that, for example, the boiler, which is the component in a power plant that heats up water to essentially turn that heat into steam that turns the turbines. The change of temperature, the rate of change in the temperature of the boiler, could be 100 degrees Fahrenheit in 15 minutes. And we notice that that is a commonality of all of the events that we have seen forced outages. So we have moved from working and dealing with an event to dealing with a pattern. And I'm kind of going through this example so that you can draw analogies to different examples and areas in your own sector and applications. As you move to the structure, here is where you say, okay, so is the why of the causes that you have been noticing. So if you have 100 degrees Fahrenheit in 15 minutes, when does that happen? So it could be that either you have a specific type of warm front that is coming through the area, or the lake temperatures get heated because of some local conditions, or you could see that the maintenance in the power plant, whenever you exceed more than 3 months, essentially the rate of change in temperature is becoming under control. It's not under control. And so that would be the structure, is what conditions lead to the causes that create the event. And it's kind of like in physics, the first 3 elements is the physics of operation. And for any data analytics expert, you can be a guru in SQL, a guru in machine learning methods, but for you to create value, you need to connect with the operations that you're trying to solve a problem with. And these 3 first tiers here are essentially dealing about the physics of operations. And that's a point I want to make, because just like in physics, you have distance or length, and the first derivative of that is velocity, and then you go into velocity and you have your first derivative, which is acceleration. Those 3 right there define the 3 derivatives of motion. In the case of operations, this analogy is the same, and you want to understand what is the why of the why, and that's your second level of your second derivative in your operations. So look at that trend and challenge your data scientists and data analytics teams to navigate through those derivatives in their understanding of the why, so that they don't get stuck in just events. So that also dollar signs increase the number of dollar signs as you move down in this pyramid that you see here. There is a higher return on investment the more quickly you can navigate to the foundation of this pyramid, and also the faster you go through this cycle. And so I see over and over again, in dozens of students that I have mentored over the years, that they get stuck in events. Sometimes they skip over patterns and they go to structure directly to predict without really understanding what is the physics of operations. And that's, I think, wrong. That doesn't help them. That doesn't help your business either. And the last point I want to make is that of the state of mind. And the state of mind, I like this one because it really is the out-of-the-box approach to operations and creating value. It is kind of a stepping back and seeing, now that I understand the physics of operation, what game changers do I have an opportunity to control today? And it could be that power plant that you have seen the issues with maintenance, that maybe you have to either change the scheduling of the maintenance. It could be that, in fact, that power plant is operating in the wrong market. And maybe you have that power plant reacting to a real-time market when, in fact, it should be a day-ahead operations, or even differently. It should be an ancillary service where you have it fine-tuned and ready to go to respond to our market conditions, but you know that when you call that power plant, it's going to respond. And so there are different market opportunities that can be explored in the state of mind approach. And people really need to take a real close look at the options, because we are, by nature, as the electric utility in general, we are kind of indoctrinated to work as we just do work. It's just the way of doing business. And I think that the market is changing so quickly that if we're not willing to challenge our basic way of doing things, I think that utilities will see one of the most remarkable changes in history of electric utilities right in front of our eyes the next 10 or so years. And so we need to continue to be vigilant because we still have assets that we have to pay for, that we have financed, and we still have to cover for those expenses. Eventually, anyone is going to pay for it, so we need to be looking ahead. What is the cheapest way that our customers can cover for that expense? So next is, oh, I have something here. So I guess it's clear by now that what moves CPS Energy is people. San Antonio is the 7th largest city in the US, and we have been making very significant investments in the last, I don't know how many years. We have been over 75 years owned by the city of San Antonio, and we have created an incredible infrastructure of AMI meters throughout our city. We are over 95, I think close to 98% already instrumented across the whole city with AMIs. And that's an investment in infrastructure. We have an incredible investment driven by our chiefs that we believe in, number one, the people of San Antonio as our owners, and that the value has to go back to them. And second, the people of CPS Energy. So you see more and more investment in the development of a workforce that is ready to leverage these new technologies. So a turning point for machine learning. So we know that machine learning has been kind of in the works since the 50s, so it's not a new subject, but for us the turning point is that open source has really helped machine learning mature past a point of academic research. And that is because it is more transparent to kind of see what the code is doing, whereas typically in the past you just have a couple of proprietary solutions that didn't let you see beyond that black box. And so whenever you are able to open the cards of the game, essentially you gain confidence and trust in what you're doing. And I think that that is where we are right now, where we feel like it's not only transparent, but we have been demonstrating to ourselves that this is something that we can actually do. We don't need, in fact, you know, we have, if I'm not wrong, we have essentially 3 PhDs in our company, including our COO, who is a PhD, but it's not the number of PhDs what makes the difference. It's the investment in our people and their enablement to create great things and to really believe in them. And so the last thing is that there is a big if statement in this turning point. And that is not a point of machine learning capability or technology. It's the last statement here. It would be a turning point only if data inputs behave within reasonable range and with normal variability. So there's a couple of things that we're yet to get better at, and that is missing data, and that is noise in the data. With the noise, we're doing better because we apply, you know, certain filters and we can improve that. The missing data aspect is something that I believe within coding we can still do better, but I don't think that we have paid enough attention to quickly. So when we think that machine learning is essentially an academic exercise, is because the guys and the faculty in universities spend an incredible amount of time just prepping their data to make the point across and write it in a paper. They write the paper and they feel like amazing, right? But go and try to take that technology or that algorithm and productionalize that, and you will notice that it doesn't work that easily. The problem is not the coding of the machine learning. The problem is that the idealistic way of data inputs going into training and into prediction is too unreasonable. And so we need to do something as an industry. And I think that to a large degree, you know, systems like the SCADA systems, the PI systems that we have in power industry at least, is one of the most reliable data sources. Maybe you don't have every second of measurement, but for sure, within a minute, you're going to have measurements that you can derive a continuous value with a 99.9% continuity in the data and good accuracy. But not all the data that we leverage today is Pi data. We have other systems that update at different rates, some at a daily rate, some at a weekly, some even once a year. And there are still parameters that are important for our methods. And the point is, how consistent are we applying those corrections or updates? Next thing here, I want to show something that, at least for me and my team, this is to the point that data like this, which, by the way, is weather in this case, but if you have been attending some of the AI and machine learning sessions, you have seen, prediction of images and videos and those very fancy models. Guess what? We may not be taking real pictures with cameras. There is a lot of different ways to look at our data that can start to behave like an image or a series of images or a sequence of images. And in this particular case, for those of you who are wondering, how do I penetrate the energy industry to demonstrate how amazing things I can do? I'm going to encourage you to just Google HRRR. That stands for High Resolution Rapid Refresh. And it's a public data set. This data set that you see right here is public. And I share this with you because if we want to recruit, and we are going to be successful recruiting people with data backgrounds into the energy industry, you need to know what is all the things that are available to you so that you can penetrate and start to create your business. So this is a very significant data set. There is over 80 different weather parameters in this data set. It's a beautiful data set. And we already started ingesting these for our local areas of San Antonio. And even, we started even archiving these for even a wider area that goes from, the states in farther north, the continent, to New Mexico and even Louisiana, because our market is all of Texas. But guess what? We know that what happens tomorrow in Texas is already being triggered by things happening in Colorado today. So we're becoming a little more sensitive to the fact that while data may not be perfect, data is coming by so quickly, and you cannot afford to lose a single day of having good, reliable data, and this is an example of one of them that you do want to ingest. Even though you may not be fully capable of processing that data today, you want to look back and say, I did the due diligence of collecting what is the most valuable with a relatively low amount of investment. This is low investment. This space is so cheap. And even though you cannot process, when you can, believe me, this becomes a gold mine for your company. And so we are already starting to process in the local area of San Antonio. And as I mentioned before, this is the kind of data that we salivate, data scientists, when we see this data and combining, particularly when you combine this data with the other data I told you about, the AMI infrastructure throughout the whole city. Imagine, for every one of those little squares, we can aggregate our customer information, such as outages for every one of those grid points. And that's one of our projects actually this year, is actually how to predict outages throughout all of our San Antonio area so that we can be more responsive to storms as they come across. And we can actually predict more accurately the amount of staffing that I need to have in order to respond to customer calls, for example. Or I can pre-deploy our technicians in the field to either check what the tree situation may be. Is the tree and the vegetation going to impact a given circuit according to our trends? Can I actually send a crew before the storm arrives so that those areas that are more sensitive to the storm can be more prepared? Can we start to avoid outages? Can we reduce that? Can we reduce the amount of customer minutes interrupted, which is actually a big metric that our CEO and chiefs are actually looking at very closely. So do the same for load forecasting, for example. So we think usually of forecasting as either a customer-driven forecast or a city-wide load forecast, because we have different markets we operate in. And to be honest with you, we work closely, and we have a great partner in Hortonworks. We have a great initial cluster, but can we digest everything we want? No, we can't. But we can certainly do great things with what we have today, and one of those would be to group our customers' data by all of those grid points. The data set, still using Spark, still using Hadoop. You need all of that capability, but for the prediction, you really reduce your data set to a place where you can manage that data set within your cluster. And then you can start to go from, before I told you, we have load forecasting for the entire city of San Antonio. We want to move to forecasting every one of those grid elements that you see here. And ultimately, we want to forecast the energy consumption for every customer. But to get there and cross the bridge, then we have to be here first. Last thing is the snapshot of where we are today. So we started our journey in 2016, so I guess it is 2.5 years in the process. We anticipate to have a production-ready environment later this month, June 2018. That's dev, QA, and production. We have been working with, we use HDFS for data storage, and we have been working with Spark for at least 10 months now. And we are in the process of integrating a little bit of a hybrid between BigDL, which is Intel's open source deep learning tool, which is optimized for CPU processing. Again, you do the best you can with the resources you have. Right now, our infrastructure is CPU-oriented. Then make the best lemonade you can make. And we're using BigDL to get our results and value creation started right away. And then next thing would be to essentially go into GPU processing of our, for training and testing, obviously. Once you have training and testing, you deploy your predictions in a much smaller cluster. And edge computing can be enabled by that also. Last couple of things is that this is a big year for us. It's a year to demonstrate. Years 2019 and forward, these are years to scale. And then the last 2 points, hybrid integration. How do we move from cloud to on-prem? That flow, we have been working to have, we have a whole team working on API development. We are turning ourselves from being huge API consumers, which we are today, to API creators. And that is driven by the fact that our CEO wants to spur innovation in San Antonio, bring startup companies, really shake things to enable better technologies for our people of San Antonio. And that means that we need to become more transparent in the way that we share data. And APIs will enable that for us. And we're also in the process of implementing a data governance program, which will have this transparency for our company. With that, thank you. Okay, so we have time for questions. Yes, sir. Have we put cost-benefit numbers to previous state to current state? No, we have not done the before and the now. Because the before and the now is, for us at least, has been before we could do what we could do with a transactional database. And if you want to do the new, the new things that we want to do, there is no comparative for us in terms of the before and after. The only thing I can compare is the cost, but the actual ability to execute on the new, I cannot execute on the new things with the prior environment. So I can only really share, not share, but I can only quantify cost before. What was the initial capital cost investment, and what is the ongoing O&M investment on that environment, which, by the way, would be very interesting to do, because I know that is quite high, as we have RDBMS environments that require a licensing model that is not very scalable, and then the new environment, which I think is more scalable. I think it would be very interesting, but we haven't, I don't have numbers to share with you. Yes, sir. Yes, sir. They are at the home, residential level or commercial. We have, yep. That's right, either to replace them or take the existing AMIs in a lab environment, retrofit those, and kind of discuss what it would take to retrofit the existing AMIs. And I have indication that our time is up. Thank you all.